This is lesson 7.6, solving radical equations. So I just want to remind you, when you're solving equations, I'm going to go back to something linear. If I had something like this and I wanted to solve, my ultimate goal is to find out what the solution, what value I could put in for x that would make this a true statement. So I'm looking for what would make this true. So in this particular case, in this particular instance, I would just start undoing this by performing inverse operations. So I would do the inverse of adding and subtract, and then I would do the inverse of multiply and divide. So my answer would be 9/2. So 9/2 is the one answer that would work in this problem. If I go back and put 9/2 in for x, that would make this a true statement. So we're going to start off with ones that are kind of easy and then work into more difficult problems. So let's start with this one. I have the cube root of x minus 4 equals 0. So I'm trying to solve this. I want to find the solution for x, the value that would make this a true statement. And with these beginning problems, you can probably just look at it and start guessing and checking to get the right answer. But we need a method for solving, so when guess and check isn't so easy, we don't have to rely on that. So again, I want to do inverse operations. So if I was solving this problem, I would find the cube root of a number, subtract 4, and get an answer. So I want to work this problem in reverse order by doing the inverse. And the inverse of minus 4 is add 4. So I have the cube root of x equals 4. So now in order to get rid of a cube root, I have to do the inverse of a cube root. And the inverse of cube rooting something is cubing, kind of like the inverse of a square root is a square. So in this particular case, to get rid of this cube root, I'm going to cube both sides. So I'm going to cube this side and cube this side. And a cube root and a cube undo each other because they're inverses. So this side becomes x, and the right side is 4 times 4 times 4, which is 64. This is the solution, the only solution. If I go back up here and check this, if I put cube root 64, subtract 4, I do get 0 because the cube root of 64 is 4, and 4 minus 4 is 0. So this solution is a good solution. In fact, it's the only solution. It's the only number that I can put in for x that makes this a true statement. Okay, let's do another example. 2x to the 1/2 power equals 200 and let's see here. I think I want to make this 50. Can't read my writing. Okay, so 2x to the 1/2 equals 50. So I want to solve this by doing inverse operations. So notice if I was working this would be the same thing as the square root. So I would find the square root of x and multiply by 2. So the first thing I want to do is get rid of the 2 by dividing both sides by 2. So when that happens, these cancel, and I get x to the 1/2 equals 25. Now we have to think about how we're going to get rid of the 1/2 power. Well, 1/2 means the same thing as square rooting. And what I really want to have here is x to the first power. So the thing that would make this be x to the first power is taking this to the 2 over 1 power. Because when I multiply now, I have 1 times 2, which is 2, 2 times 1, which is 2, and 2 over 2 is 1. So these, being the reciprocal, are just going to cancel out. So since I took this to the 2 over 1 power, I have to also take this to the 2 over 1 power. So then I'm going to square 25, and the square of 25 is 625. Let's do another example. The square root of 2x plus 8 minus 4 equals 6. All right, I want to undo by squaring. If I knew what this number was, I would square root it, and then I would subtract 4, and I want to get 6. So this part happens first, so in reverse order, it's going to happen last. So the first number I need to get rid of is the 4. So I'm going to do that by adding 4 to both sides. I get square root 2x plus 8 equals 10. The next thing I want to do in order to get to that x is undo the square root. And the way you undo a square root is by squaring. So I'm going to square both sides. And when you square a square root, they cancel each other out. So the left side is 2x plus 8. And on the right side, I have 10 squared, which is 100. And then I'm going to minus 8 from both sides. So I get 2x equals 92. And then divide both sides by 2. And I get x equals 46. So 46 is the solution. Let's go see if it works. 2 times 46 is 92. 92 plus 8 is 100. The square root of 100 is 10, and 10 minus 4 is 6. So because 46 actually works here, 46 is the solution to this problem. Okay, let's do one more example on this video, and then we'll switch to something different. Here's the next example, example 4. The square root of 4x plus 28 minus 3 square root 2x equals 0. So the first thing I want to do on this one is kind of caution you. A lot of people would say on this one, because we have a square root, the first thing we need to do is square both sides, and that's not true. The only time you want to square both sides is whenever you're up at a problem like this, where all you have on one side is a square root. Notice on this problem, I have a subtraction. So I don't want to square both sides, because if I did that, like let's say I had x add 2 squared, that would be x plus 2 times x plus 2. So I don't want to do squaring when there's still a minus or a plus here. So on this particular problem, I want to start by putting the square root on the other side. So I'm going to add the negative 3 square root of 2x to both sides. So I'm going to move this over here so it becomes positive 3 square root 2x. So now that I have a radical by itself on one side or the other, I know that I'm going to start by squaring. So I'm going to square this side, and then I have to square everything on this side. So on the left side, I have 4x plus 28. And on the right side, I have to square the 3 and the square root of 2x. The square root of 3 is 9, and the square of square root 2x is just 2x. So I have 4x plus 28 equals 18x. So 28, I'm going to subtract 4x from both sides, equals 14x. So x equals 2. Let's go up here and see if that works. If I put a 2 right here, 4 times 2 is 8. 8 plus 28 is 36. So I would have the square root of 36. If I put a 2 right here, I'd have 2 times 2, which is 4. And the square root of 4 is 2, so I'd have minus 3 times 2. The square root of 36 is 6. 6 minus 6 is 0. So because this is a true statement, that means this must be a solution.